So in our last video we saw that slope was a number that describes a line, and it describes the steepness and direction of the line. Whether it's going uphill or downhill from left to right is determined by whether or not the slope is positive or negative. And how steep the line is the magnitude of the slope. A slope that is far from zero is going to have a fairly steep slope. A slope that is close to zero will have a fairly gentle slope. Well, there's a way that's set up into a formula. Okay. The slope of a line is equal to how much a line rises over a certain interval divided by how far it runs on that interval. Okay, we'll talk about that for a minute. Another way to think of it is change in y. Y is our up and down coordinates on the Cartesian coordinate plane, right? So how much does y change between 2 points on the line divided by how much x changes? And the weird thing's going to be is even though depending on which 2 points you choose, the change in y will be different, the change in x will be different, but this fraction made by calculating change in y divided by change in x is going to be the same for all pairs of points on a given line. And finally, there's this formula you see in the book. It says the exact same thing. It says take a point number 2 and a point number 1. What's the difference between the y value of point number 2 and the y value of point number 1? Divide that difference by the difference in the x value in point number 2 minus the x value in point number 1. Which point is number 1, which point is number 2, it won't matter. We'll see. What will matter is whenever you pick a point number 2, that y goes first, then the x from that same point must be first. The second is because it's a ratio of rise over run, the change in y over the change in x, it's important that the y change, the y difference goes in the numerator and the x difference goes in the denominator. Let's set up a problem and see if we can find the slope here. Okay, so we're going down. Let's go with the line tool here first. Okay. Okay, here's my y-axis, and there is my x-axis, and then in gray I am going to make a line. Okay, and let's say we know that this line contains, we know the coordinates of 2 of the points on this line. Okay, one of those coordinates is the point, make the dot nice and big for that point. It's going to be the point 1, 4. Okay, and the other is going to be, we know this point is the point -2 equals x, 2 equals y. So let's say we know the coordinates of these 2 points. Let's find the slope. Well, the slope is going to be equal to the y of one of these points minus the y of the other. And I will just choose this point here as my point 2. And this is my point 1, but it won't really much matter which order we choose them. The difference in y's is going to be 4 minus 2. Okay, so going from here to here, we've gone up 2 units. The change in x is going to be, now because I started with this point's y, downstairs I have to start with this point's x. and then I subtract this point's x, but this point's x is a negative. So this becomes 2 on top. 1 minus negative 2 is the same as 1 plus 2, or 3. So this line has a slope of 2/3. And now a good check, because we can often brain fart when we're calculating slopes, a couple of good checks goes back to that last video. First of all, we notice this slope is positive. Is it appropriate for this line to have positive slope? You betcha, because it's going uphill. Is it appropriate for this line to have a fairly gentle slope? That's harder because I just winged the drawing, and so we don't know if the scales of the axes are very accurate, but it's appropriate looking anyway because this is going up at a relatively gentle pace. It's going up at less than a 45-degree angle. We expect those to be fraction slopes, or slopes that are truly less than 1. Okay, so it's going uphill, it's going gentle, that's what this slope says, so we can be reasonably confident that we didn't screw up in calculating it. Hope this helps.